Hello dears, welcome back to JK Chemistry. Today, I'm going to give you a trick. This trick is basically based on Cram rule Felkin Anh model. Moreover, Cram Chelate model. As we know, these rules or this model we are applying in the context of nucleophilic addition reaction to carbonyl compounds having chiral center at alpha carbon. Let's start without any delay. As we mentioned earlier, we know that nucleophilic addition reaction in carbonyl compound. Generally, if you have a carbonyl compound like this, if you do nucleophilic addition to this, a nucleophile, so if you do nucleophilic addition to this compound, what will happen? You will end up with a tetrahedral intermediate, right? You will end up with a tetrahedral intermediate. Here it is O minus, and your nucleophile comes to this position. So this is the picture. After protonation, you will get this OH, right? After protonation, you will end up with this product, nucleophile here. Here, there is no meaning for stereochemistry. Here we are represented in relative stereochemistry. The end story will be changed if you have a chiral center at alpha carbon. So this is your carbonyl carbon, and here it is alpha carbon. In this compound, your alpha carbon is chiral center. Chiral center means 4 ligands are different. Okay. Now, in this scenario, we are applying aforementioned models, that is Cram model, Felkin Anh model, Cram Chelate model. So, for what purpose? The purpose is that, listen here, if you do nucleophilic addition to this compound, here nucleophilic addition to this carbonyl compound, two possibilities are there. What are they? Either this nucleophile can attack above the plane, or top phase attack may take place. Top phase means your nucleophile becomes on wedge, or your nucleophile can approach bottom phase, through bottom phase. In that situation, your nucleophile takes a position at dash position. Okay. So two possibilities are there, but you remember that nothing will happen to this chiral center. Chiral center remains the same, no stereochemistry change. The stereochemistry play at this carbonyl carbon only. So two possibilities are there. Either your nucleophile can takes a position at the verge or dash. Now the question is that among these two, which one is the major product? Which one is the major product? That is the main question. So we want to identify the major product among these two. One is the major product. So these two are related as diastereomers. That's why this kind of reaction termed as diastereoselective reaction. It's a selective reaction. That means one is major product, one is minor product. So that is selective. Since the products are related as diastereomer, this termed as diastereoselective reaction. So the question, among these, which one is the major product? How will you identify? For that, we are applying Felkin Anh model, Cram model, and moreover, Cram Chelate model. But these models are exhaustive. So somewhat difficult to play with these. In order to learn easily, in order to identify our major product in better way, we are going to give you a small trick, a simple trick. So we can continue. First of all, before starting our tricks, we want to know two terminology. That is relative stereochemistry of carbonyl compound. Here we are mainly focusing on carbonyl functional group and your one of the substituent in the alpha position. In the alpha position, you can have three substituent, right? Since carbon is tetravalent, among one is connected to your carbonyl carbon and other three are different. So here we are classifying L, it means large group, M means medium group, S means small group in the sense that their size, atomic size. Okay. Among this MSL, we are focusing on large group and carbonyl carbon. If these two align in this fashion, carbonyl carbon in the plane of paper, carbonyl function group in the plane of paper, and moreover your large group in the plane of paper, if they are aligned this fashion, right? So its stereochemistry is relative stereochemistry is anti. That means anti. That means they are opposite. While we are classifying based on dihedral angle theta, it should be 180 degree. So this relative stereochemistry is called anti. What about syn? If your carbonyl function group and your large group are close to with each other, they are termed as syn. Here in the syn, their dihedral angle will be 0. Dihedral angle will be 0. These two terminology is very important. You should know about this terminology. I'm repeating, anti means your carbonyl function group and large group both should be in the plane of paper. That is very important. Should be in the plane of paper. If their dihedral angle is 180, it is termed as anti. If their dihedral angle is 0, it's termed as syn, and both should be in the plane of paper. Okay. Now we are move on to the first trick. In this scenario, we are mainly dealing with the Cram model or Felkin Anh model. So our outcome is whatever you are going to predict by using Cram model and Felkin Anh model, we end up with the same product. No problem with this trick. Okay. So while we are moving to this trick, the first point is that your large group is anti. First situation, your large group is anti position. So this is your large group anti position. In that scenario, nucleophilic attack from the small side group takes place. That is important. If your structure is given in which your large group is anti and both should be in the plane of paper, that is very important. Okay. Both should be in the plane of paper. Carbonyl functional group and the large groups are in the plane of paper. That is very important. Okay. First, large group anti. In that scenario, your nucleophilic attack. Here, nucleophile will attack on this carbonyl carbon. And our prediction is that in this case, these nucleophilic attacks takes place from the position of smaller group. Okay. Smaller group, here you can see that your small group in the dash position, that is bottom face. So you nucleophile can attack via bottom face. Your nucleophile should be in dash as in the case of small group. Got it? Okay. Now this O minus become protonated, it becomes OH. It becomes OH. Okay. Next situation, if your large group syn with carbonyl group, large group syn with carbonyl group. In that scenario, what will happen? Nucleophilic attack takes place. Now our question, in which phase? So rule says that In this situation, if large group syn with the carbonyl group, nucleophilic attack takes place from the face of medium group. Here we can see that medium group in wedge. So nucleophile can attack from the top face. That means nucleophile will be in wedge as in the case of medium group. Medium group present in wedge as well as nucleophile present in the wedge portion. So got it? First, if large group anti with the carbonyl function group, nucleophile attack takes place from the small group side. If large group syn with the carbonyl group, nucleophilic attack takes place from the side of medium group. Okay, these two are 2 points. Okay. Next, now we are applying another trick. Here we are going to predict the product as in the case of Chelate model, Cram Chelate model. Here the scenario is just opposite to whatever we discussed in the earlier case. In the earlier case, anti attack takes place from the small side. Syn attack takes place from the medium side. Here you can see that if it is syn, attack takes place small side group. Okay. Small side. Okay, small group side. Okay. And if large group is anti, attack takes place from the side of medium group. It's just opposite to the whatever we are discussed. So here the outcome is mainly based on Cram-Chelate model. The point is that here we should have chelation. Chelation means you already learned about that terminology. Suppose if you have a metal center and if you have a ligand having lone pair electron, let's say water molecule having lone pair electron. So there will be a dative coordinate bond between that ligand and metal. Here, in this case, we are also expecting a chelation between one of the group in the alpha position. Here we are treating our large group as a ligand. Here large group should be heteroatom. Large group should contain heteroatom. Generally, large group should be OR, NHR, SR. So heteroatom means it should have lone pair electron. So this heteroatom can coordinate with a metal. So here you can't see any metal in the compound, right? So metal from where? Metal should be from your reagent. So this metal from the reagent you are using. Usually reagent containing magnesium, zinc, copper, titanium, cerium, manganese, these ions can coordinate with the heteroatom like oxygen, nitrogen, sulfur. So there is a dative bond between this heteroatom and these metal present in the reagent. Okay, reagent. Generally, we are using reagent, Grignard reagent, RMgBr. It can show chelation. So another cerium chloride, Cl3, that can show chelation. Okay. Now, if you have a reagent having only sodium and potassium, it won't show any chelation. So check that your reagent having these metal, then there will be a chelation. So you should use this trick 2 rather than trick 1. Okay, right. If you apply trick 1, your large group syn with your carbonyl function group, then the nucleophilic attack takes place from which side? Your smaller group side. Here smaller group in dash, your nucleophile will be in the position of dash. That means bottom face. Now, if large group anti with the carbonyl group, what will happen? Nucleophilic attack from where it takes place? In this scenario, attack takes place from the side of medium group. If your medium group in wedge, then your nucleophile will be in wedge. So you can easily see that these two are just opposite to the previous case. So you have to learn one situation. You can learn one situation as mentioned earlier, then you can just opposite. See, this is our rule. Okay, that is your anti small attack takes place from the small side. Okay, anti, then sin attack takes place from the medium group. Okay, medium group. Then if there is any chelation, you just reverse it. Okay, just we can make a table. No chelation and chelation. No chelation means anti attack takes place from the side of small group. Okay. Then sin attack takes place from the side of medium group. If there is any chelation, it will just opposite. Okay. That is, if it is anti attack takes place from the side of medium group. If it is sin, attack takes place from the side of small. Okay. This is the trick. You have to learn only this one. Okay. Then you can predict your major outcome. Okay, fine. Now, another problem is that certain situation, your large group won't be in the plane of paper. That is another problem. In the previous case, we have seen that your large group in the plane of paper. If your large group not in the plane of paper, you want to convert into the plane of paper. How will you convert? You just rotate your CC bond. You just rotate your CC bond. Let's see, you can see two situations. First situation in which your large group in the wedge, that means top face. You want to rotate in certain extent, such a way you want to make your large group in the plane of paper. How will you do that? You just rotate in the clockwise direction. That means you just rotate this to this direction. What will happen? Your large group will be in the plane of paper. Relative motion will take place. Accordingly, small group move like this way, medium group move like this way. This kind of rotation you are doing. Okay, this kind of rotation. So large group in the plane of paper, small group in dash position, medium group will be in the wedge position. Then you can apply your rule depend upon your reagent. If it is if there is no chelation, we have prepared a table, no chelation and chelation. Chelation in the case of no chelation, anti attack takes place from the small side, sin attack takes place from the medium side, anti in the case of chelation, attack takes place from medium side, sin attack takes place from the small group. Okay. So accordingly, depend upon reagent, you can apply this rule. Okay, this rule. This is a shortcut, not rule that we developed. It is not standardized. Okay. Another situation in which your large group in dash position, what we will do, you want to make it in the plane of paper. You just do anti-clockwise rotation in which your rotation in this way. Okay. So what will happen? Large group in the plane of paper, small group in the wedge position, and medium group in the dash position. Accordingly, you can do this rotation. In certain situation, you want to do another kind of rotation. Suppose your compound is given like this, R, and here large group, here medium group. So if your option showing alignment like this, that is like this. That means you want to rotate end over rotation. Here you want to perform end over rotation. How will you do? End over rotation means you are rotating like this, end over rotation. L group here, R group here. You be careful that a change in this position. Actually, C2 rotation you are doing. In this situation, your medium group in the wedge portion and the small group in the dash portion. If you do this end over rotation or end over rotation, what will happen? Stereochemistry will be changed. That means your small group will be in dash, sorry, wedge, and medium group will be in dash. Okay, right. That kind of change will happen. Depend upon your problem, depend upon your option, you may do all these practices. Okay, right. Here we are doing end over rotation. Okay, clear? Right. So these are the tricks. You have to remember all these. Okay, let's do a problem, an illustrative problem. Listen here. I'm giving a compound like this. Here it is pH. Here it is OMe. Okay, and here it is CH3. And here it is wedge CH3 and dash H. And here we are doing two reaction in the same substrate with a different reagent. That is the difference. First, I am taking sodium borohydrate, NaBH4. Another situation, I am taking Me. Okay, MeMgBr, Grignard reagent. Here, first of all, we want to analyze our given substrate. Given substrate, this here we can see carbonyl functional group and the large group. Large group here it is OMe, right? Moreover, this is heteroatom. Moreover, this is heteroatom. This is carbon, this is hydrogen, this is oxygen. So clearly, this is your large group, this is your medium group, this is your small group. Now, your large group and your carbonyl function group, they are in the plane of paper, and moreover, they are syn with each other. They are syn with each other. So your substrate is syn. First of all, you have to identify whether it is syn or anti. Now it is syn, clear. Then, first of all, check your reagent. Sodium borohydrate, you know that this is a reducing agent, and this reducing agent readily give you a nucleophile that is H minus. It readily give you a nucleophile as a H minus. Okay, right. Now you got a nucleophile and your reagent. There is no metal that's showing a chelation. So here you can easily say that no chelation. No chelation. Now your stereo outcome is based on no chelation situation. And here we can say that it is syn, right? This is syn. In the syn, no chelation. What will be the stereo outcome? We have learned that in the case of syn, no chelation, right? Your stereo outcome is based on medium group. So attack takes place from the side of medium group. Okay, medium group. Okay, attack takes place from the side of medium group. Here, medium group in the wedge. Okay, so I am drawing the structure. First of all, you want to keep this alpha chiral carbon as such. So CH3 in wedge, no change at all. Hydrogen in dash, OMe in the plane of paper. Your reaction takes place on this side, right? So the rule says that attack takes place from the side of medium group. So your nucleophile, what is your nucleophile? Your nucleophile is H minus. So it will be in the same position as it is present in the case of medium group. So medium group in wedge, your nucleophile will be in wedge, and OH OH will be in dash. So this is the major product here, right? So, right. Okay. So nucleophile will be in the same position as it is present in the case of a medium group. Now, second situation. Situation, you can see easily a magnesium Mg2 plus. It can show chelation with the compound. Now, here chelation play. It based on Cram chelate model. And moreover, your compound is syn. In the case of syn, we have learned that in the case of chelation, syn, if your compound is syn, your nucleophilic attack takes place from the side of small group. Small group. Okay. Now I'm drawing the product. Keep your substrate as the same in alpha chiral center. Now no change at all. Now your attack takes place from the side of small group. Your small group is hydrogen. It is in the dash. So nucleophile, here your nucleophile is Me, right? Here your nucleophile is Me minus, that is CH3 minus. So CH3 minus will be in dash, right? CH3 minus will be in dash, right? Okay, then your OH will be in wedge. Okay, this is the major product. I hope you get the concept, right? Okay, we can check another problem in which I am giving substrate as pH, double bond O, Me, and here OR. Now it is treated with CH3 MgBr. It is treated with CH3 MgBr. Okay, fine. Now, first of all, while we are analyzing the substrate, how can you predict it is syn or anti? The problem is that the problem associated with this structure is that your heteroatom or large group. Here we can classify this is large group, this is medium group, and here moreover you can see a hydrogen, that is a small group. Now the problem is that your large group not in the plane of paper. That is the problem. First of all, you want to convert your large group or heteroatom in the plane of paper. Then only you can predict whether the given compound is a syn or anti. Okay. In order to convert this R in the plane of paper, you have to do rotation. How will you do that rotation? You want to rotate in the anti-clockwise direction, right? You want to rotate in the anti-clockwise direction. Okay, so in that situation, what will happen? OR move to this side, Me move to this side, and H move to. Okay, we are doing. Okay, OR move to this side, H move to this side, right? Then your structure will be like this: pH, double bond O. Now what will happen? OR becomes in the plane of paper. Now Me will be in the wedge position. Then H will be in the dash position. Now you can easily apply our trick. Okay. Now you can apply our trick. This is a syn. Then chelation will be the right. Heteroatom is here. This is heteroatom. And your reagent having Mg2 plus. So chelation will be there. Now according to our trick, syn, if there is chelation, nucleophilic attack takes place from the side of small group. Okay, nucleophilic attack will take place in the side of small group. So accordingly, our predicted product will be no change with this structure. Okay, OR, and ME, H. Now you are a small group in dash. Okay, small group in dash. So your nucleophile is CH3. CH3. Here nucleophile is CH3 minus. That will attack from the top bottom face. It will be in dash as in the case of hydrogen. So CH3 here, or okay, CH3 here, and your OH will be in wedge. Okay. Okay. Now this is the major product. Maybe the problem is that maybe in your option, you can't see this structure. That means OR will be in dash as in the case of substrate. There may be chance. Then in that case, you want to do small malpractice. That is the same structure, no change at all. pH, your product will be CH3. This new chiral center, no change here. Okay. But my idea is that I want to make the structure as same as your substrate, like this. Here the change already happened in the carbonyl compound. Nucleophilic attack happened. Here your nucleophile was CH3, and CH3 minus attacked from the bottom face, right? Then it attain a dash position, and OH will be in the wedge position. Now I want to keep this portion. Which portion? This portion as same. Here it is different, right? Here ME in wedge, here H is dash, or in the plane of paper. But I want to convert back. That is, I want to make OR in dash. In that case, you do just a rotation or previous rotation, or aim is that I want to make ME in the plane of paper. So you want to rotate in clockwise direction. In that case, ME becomes in the plane of paper, OR will be in dash, and the hydrogen will be in wedge. So what will happen? If you do clockwise rotation, your ME will be in the plane of paper, ME will be in the plane of paper, and OR will be in dash, then H will be in wedge. Okay, so this is the answer. So you can convert like this way. Okay, both are the same. Structurally, both are the same. Okay, actually, this is new stereo center. This is a alpha center, but here stereochemistry will be the same, no problem. So this is the answer. Okay, fine, clear. Okay. Now this is a multiple choice question, right? You can easily apply our trick and you can easily find the answer. Actually, this is a JAM question, JAM 2021. It's conducted by ISC Bangalore. So in the case of a JAM student, this Felkin Anh model, everything is not familiar, right? So here you can apply our trick, then you can find the answer easily. See, this is your substrate, this is your alpha carbon. Here the group, this is the large group, this is medium group. Here you can have hydrogen, that is small group. Okay. And moreover, while we are checking the substrate, large group and carbonyl group, they are in the plane, and moreover, it is syn. If it is syn, there is no chelation, right? Sodium borohydrate, no metal, no chelation. No chelation. Here we can find no chelation. So what will happen? If it is syn, attack takes place from the side of medium group, right? Attack takes place from the side of medium group. Okay, that is our conclusion. Now you can remove some option easily. See, here we already mentioned that relative structure of the substrate will not be different. Okay, so here we can see your alpha carbon, Me in wedge, hydrogen in dash, right? Alignment, everything is same. Here, this is a alkyl chain. This is alkyl chain. Every compound showing alkyl chain to the left position, right? But Me should be in wedge. This option showing Me in dash. This option showing Me in dash. So these two options you can easily omit it. Okay. Now, according to our trick, if your compound is seen, if there is no chelation, attack will take place from the side of medium group. Here your medium group in wedge. So your what is your nucleophile here? Your nucleophile is H minus. So H minus will attack via top face, that is above the plane of paper. So hydrogen will be in wedge. Hydrogen will be in wedge. See here OH in dash, so your hydrogen, here it is your hydrogen in wedge. Here OH is wedge, then your hydrogen is dash. So according to our trick, your medium group in wedge, so your nucleophile should be in wedge. So your correct answer is option C, right? Clear? So that's all. I hope you find this video very helpful for your future endeavor. Thank you.